Bismillahirrahmanirrahim. Assalamu alaikum students. This is your chemistry teacher Farzana Nazir. Today we are going to continue our chapter 7, that is about electrochemistry. Today we are going to discuss oxidation state, rules for assigning oxidation state, oxidizing and reducing agents, methods for identifying oxidizing and reducing agents. After going through today's lesson, students will be able to define oxidation state, oxidizing agent and reducing agent. They can easily determine the oxidation number of an atom of any element in a compound. They can identify the oxidizing and reducing agent in a redox reaction. Now let us start our today's lesson. Today we are going to discuss oxidation state. Oxidation state or oxidation number is defined as the number of charges an atom will have in a molecule or a compound. Oxidation state is used to identify an atom which is oxidized or reduced in a redox reaction. The element that shows an increase in oxidation number is oxidized, whereas the element that shows a decrease in oxidation number is reduced. For example, let us consider the reaction between copper oxide and hydrogen. In this reaction, the oxidation state of copper in copper oxide is positive 2. After reacting with hydrogen, it forms copper and its oxidation state becomes 0. Since the oxidation state of copper during the reaction decreases from positive 2 to 0, therefore copper is reduced in this reaction. On the other hand, oxidation state of free hydrogen element is 0. After reacting with copper oxide, it becomes H2O, that is water. Now the oxidation state of hydrogen after reacting is positive 1. Since the oxidation state of hydrogen increases from 0 to positive 1, therefore hydrogen is oxidized in this reaction. There are certain rules for assigning the oxidation state or number to an element in a compound. Now let us study these rules in detail. Rule number 1. The oxidation state of any uncombined or free element is always 0. For example, the oxidation state of zinc, sodium, H2, Cl2 is taken 0. Rule number 2. In simple ions, oxidation state is same as their charges. For example, oxidation state of sodium in Na positive 1 is positive 1. The oxidation state of calcium in Ca positive 2 is positive 2, whereas the oxidation state of aluminium in Al positive 3 is taken positive 3. Rule number 3. In a complex ion, the total sum of oxidation state of atom is equal to the charge on their ions. It means in case of ions, the sum of oxidation states of each element should be equal to the charge on the ion. For example, in SO4-2, to find the oxidation state of each element, we will use the following equation. That is oxidation state of sulfur plus oxidation state of oxygen multiplied by 4 because there are 4 atoms of oxygen is equal to minus 2. Minus 2 is the total charge on the ion. Similarly, in case of ammonium ion NH4 positive 1, to find the oxidation state of this molecule, we will use the following formula. Oxidation state of nitrogen plus oxidation state of hydrogen multiply 4 is equal to charge on the ion, that is positive 1. Rule number 4. The oxidation number of each of the atom in a molecule or compound count separately and their sum is 0. This is in case of neutral molecule. In case of neutral molecule, the total sum of oxidation state of atoms is equal to 0. For example, in HCl, the oxidation state of hydrogen is positive 1. Oxidation state of chlorine is minus 1. The sum of the two oxidation state of elements in a molecule should be equal to 0. Similarly, in case of NaCl, the oxidation state of Na is positive 1. Oxidation state of chlorine is minus 1. Since molecule is neutral, therefore the total oxidation state of NaCl should be 0. Oxidation state of some elements in binary compounds that rarely changes. In this table, you are provided with some elements from the periodic table whose oxidation state rarely change. For example, all the elements of group 1A have the oxidation state positive 1. Elements of group 2A show the oxidation state of positive 2. Group 3A show the oxidation state of positive 3. All the elements of group 7A have oxidation state minus 1. Hydrogen in most of the cases have oxidation state positive 1, except in case of metal hydrides where its oxidation state is minus 1. Oxygen in most of the cases have oxidation state minus 2, except in peroxide and in OF2 where its oxidation state is minus 1. Now, how to determine the oxidation state of atom in a compound? In order to determine the oxidation state of an atom in a compound, we will use rule 1 to 4 and table of oxidation state to get as many oxidation numbers. We will use rule number 4 to get oxidation number that has not been assigned. Let's find the oxidation state of chromium in K2Cr2O7. The oxidation number of potassium is plus 1 since it belongs to group 1A. There are 2 potassium atoms, therefore overall oxidation number for potassium is plus 1 multiplied by 2, that is plus 2. Suppose oxidation for chromium is X. Since there are 2 chromium atoms, therefore overall oxidation state for chromium is 2X. There are 7 oxygen atoms, therefore overall oxidation state for oxygen is minus 2 into 7, that is minus 14. Since K2Cr2O7 is a neutral molecule, therefore the sum of oxidation numbers must be 0. By calculating for the value of X, X is equal to plus 6. It means the oxidation state of 1 chromium in K2Cr2O7 is plus 6. Now let us find the oxidation state of sulfur in H2SO4. As we know, the oxidation state of hydrogen is plus 1 into 2 plus oxidation state of sulfur is X, which is to be calculated, plus oxidation state of oxygen, which is minus 2 into 4. Since the molecule is neutral, therefore the sum must be equal to 0. Now calculating for the value of X, we find that the X is equal to plus 6. It means the oxidation state of sulfur in H2SO4 is plus 6. We can also write the oxidation state on top of the molecule as plus 1 into 2 for sulfur, plus 6 for oxygen, minus 2 into 4. The total sum of positive and negative charge must be 0. Let's look at another example. To find the oxidation state of oxygen in H2O2, the oxidation state of hydrogen is again plus 1 into 2. Oxidation state of oxygen is to be calculated, that is 2x is equal to 0. The value of x is equal to minus 1. It means in this case the oxidation state of oxygen is minus 1. Now the oxidation state of hydrogen is plus 1 into 2. Oxidation state of oxygen is minus 1 into 2. Both positive and negative cancel each other. Therefore, the molecule is a neutral molecule. Today's next topic is oxidizing and reducing agent. In order to understand the concept of oxidizing and reducing agent, let us watch an activity first. In this activity, we are going to take KMnO4 as oxidizing agent, dilute sulfuric acid, and iron sulfate as reducing agent. Take 10 cubic centimeter of potassium permanganate in a beaker. Now add few drops of dilute sulfuric acid in this solution. Note the color of KMnO4. It's purple in color. Now we are going to add reducing agent iron sulfate slowly in this solution. Continue to add reducing agent until there is no change in the color of KMnO4. Means the color of KMnO4 is discharged. In this reaction, KMnO4 is reduced by ferrous sulfate. It means ferrous sulfate is reducing agent. The oxidation state of manganese has been decreased from plus 7 to plus 2. Oxidizing agent. An oxidizing agent is the reactant containing the element that is reduced, gain electrons in a chemical reaction. An oxidizing agent is a substance which oxidizes others and itself it is reduced. It gives oxygen to another substance. Some common examples of oxidizing agents are Fe2O3, H2SO4 and KMnO4. These are all most commonly used oxidizing agents. Reducing agents. A reducing agent is the reactant containing the element that is oxidized lose electrons in a chemical reaction. A reducing agent is a substance which reduces others and itself it is oxidized. It removes oxygen from another substance. Consider the following reaction that take place in the manufacture of steel. Iron oxide Fe2O3 reacts with carbon monoxide to form iron Fe and carbon dioxide. To identify the oxidizing and reducing agents, we have to work out the oxidation states of all the elements involved in the reaction. Now, in this reaction, the oxidation state of single iron is in the reactant is positive 3, whereas oxidation state of oxygen is minus 2. In carbon monoxide, the oxidation state of carbon is positive 2, whereas the oxidation state of oxygen is minus 2. The oxidation state of free element Fe is 0. The oxidation state of carbon is positive 4. The oxidation state of single oxygen is minus 2. In this reaction, iron is being reduced because there is a decrease in its oxidation state. The decrease in oxidation state is from positive 3 to 0. Whereas carbon is being oxidized because there is an increase in oxidation state. The oxidation state of carbon increases from positive 2 to positive 4. The reactant carbon monoxide contains the carbon that is being oxidized. So, carbon monoxide is reducing agent. The reactant Fe2O3 contains the iron that is being reduced. So, Fe2O3 is oxidizing agent. Remember, oxidizing and reducing agent is the whole molecule or formula unit and not the atom that has undergone change in oxidation state. Example 2. Zinc react with lead oxide to form zinc oxide and lead. To identify the oxidizing and reducing agent in this reaction, we will first work out the oxidation states of all the elements involved in the reaction. In this reaction, the oxidation state of zinc increases from 0 to plus 2. Therefore, oxidation takes place. Whereas, the oxidation state of lead decreases from plus 2 to 0. Therefore, in this reaction, reduction takes place. Since the oxidation state of zinc increases from 0 to plus 2, therefore, zinc is reduced in this reaction. Whereas, oxidation state of lead decreases from plus 2 to 0, therefore, it is reduced in this reaction. So, lead oxide is the oxidizing agent and zinc is the reducing agent. Now, let us have a review of what we have studied today. Oxidation state or oxidation number is defined as the number of charges an atom will have in a molecule or a compound. The oxidizing agent is the reactant containing the element that is reduced in a chemical reaction. Reducing agent is the reactant containing the element that is oxidized in a chemical reaction. Now, at the end of today's lesson, I am going to give you some questions which are related to oxidation state and oxidizing and reducing agent. Question number 1. Find the oxidation state of sulfur in the following compound. A. H2S, B. H2SO4, C. Na2S2O3. Use the different rules for assigning the oxidation state to an atom in a compound. Question number 2. Magnesium react with water to form magnesium oxide and hydrogen. You have to find the oxidation states of each element in the reaction and then fill the following blanks given at the bottom. You have to find which element is oxidized, reduced, find the oxidizing agent and reducing agent.